solar theory, and it is formed. The rotating cloud is called as solar nebula. Okay. Now comes layers of the earth. Now let's see. If you consider page 14, why earth is considered as a system, because earth has different parts and all parts work for a functioning of the earth. That's why earth is considered as a one single system. And there are different parts of the earth. The earth has different spheres. So let me come to that part. Hang on. Okay, we'll come back. So how did the earth has different layers also? Now when earth was hot, when earth was hot, material started cooling. So when it started cooling, what happens? When it cools, they come together, crystals, they become heavy, they fall off, right? They're heavy. So what happens is that they form different layers in the earth. That's why. So you see, the center, earth has 3 layers. As earth formed, the decay of radioactive elements and the heat from high velocity impacts caused the temperature of the earth to rise. And this rising gave rise to lighter rocks because they become more buoyant, lighter. Between cold air and hot air, which one is more lighter?
Cold.
Which one rises?
Heat.
So hot air, right? That's why we all heard about hot air balloons. We never heard about cold air balloons, right? Hot air, that's become lighter. It rises. Likewise, anything which is lighter, because the light material of the earth become lighter and they started floating towards outward. And then when it started floating and it became solid, that's why you have Earth's crust. Crust is solid, Earth's crust, towards the surface. Then gaseous materials from those crusts escaped into the atmosphere and it gave rise to atmosphere. That's what the Earth's interior escaped from the interiors of the Earth and to produce primitive atmosphere. So all the gas, before there was nothing there, then they gave rise to primitive. All this theory is like a Big Bang theory. But the people who believe in a biblical view, this is entirely different. God created in 7 days, right? It's called a special creation. Okay. Okay, let's see. Now, since why Earth is considered one single system, because Earth comprises different spheres. Let's see what are the first one. Hydrosphere. Ocean is the most prominent feature of the hydrosphere. Why? Because Earth is surrounded by nearly 71% of the Earth is surrounded by Earth's surface, by water. And it holds about 97% of the Earth's water. So it's big oceans. If you see the oceans, they contain 97% of the water, oceans. Remaining all other 3% is all on those lakes, ponds, streams, canal, all those things. But major is in that oceans. Rivers, seas are smaller portions. Also includes fresh water found in streams, lakes. So this hydrosphere is not just oceans. It also includes fresh water which are found in ponds, streams, lakes, glaciers also, and that anything is underwater, which give rise to water table. So that also comprises hydrosphere. So hydrosphere is one. Next one is called atmosphere. What is the second one? It's a thin, tenuous blanket of air. That's called atmosphere. And that lies. So if you go up about 3.5 miles up, our atmosphere is only about 3.5 miles above, which is 5.6 kilometers. And after that, there is no atmosphere. So when somebody climbs the Mount Everest or mountains which are tall, why they feel breathless? Is there oxygen above? As you go higher and higher, what happens to the oxygen? It thins out. Good job. There is no atmosphere. There is no atmosphere. It becomes thins out. That's why oxygen. So in the atmosphere, which is the most? Now I'm going to ask this question: which is the most abundant gas in the atmosphere?
Hydrogen.
Which one?
Hydrogen.
No.
No.
In the atmosphere. In the universe, it's hydrogen. In the atmosphere, I'm going to share a whiteboard. I'm going to go, for the people who are online, I'm going to share whiteboard and I'll come back. Can you all see my whiteboard?
Yes.
Okay, good. Okay, so the most abundant gas in the atmosphere is nitrogen, which is given as N2. And this is 70. So 70, almost like a 78% is nitrogen. Then what is the next, which is the next gas which is most abundant? What is this gas? Oxygen, and this is 21%. So what is 78 plus 21? 99. So 99% is only these two gases, and remaining all other pollutants, all other gases, noble gases, carbon dioxide, carbon monoxide, sulfur dioxide, sulfur trioxides, all other toxic gases, everything is only that 1%. And this is a homogeneous mixture. So if I collect the atmosphere, the gas in Arkansas, and I go to Texas and collected the gas, the percentage of the atmosphere is always same. That's why this is called as a homogeneous mixture. It has a uniform mixture, concentration. That's why these are the two gases. So as you go higher and higher, the oxygen content goes down less and less. But as you go higher, there is no other gas, there is no oxygen, it's only hydrogen gas. That's why universe has mostly, in the universe, in the space, there is only hydrogen gas. There is no other gas. That's why close to the sun, there is only hydrogen gas. Okay, can you all see my slides back? Can you all see my slides back?
Yes. And
Okay, thank you. I just want to make sure, that's why. Okay, so the atmosphere is a thin blanket of air, is called as atmosphere, and it only about 3.5 miles up. Afterwards is different. You're going to study different layers of the atmosphere later in the chapter, later chapters. When in the last chapters you'll learn that. Now the third sphere, which is called biosphere. Are we a part of biosphere? Do we have life in us?
Yes.
That's why I'm teaching earth science, right?
I mean, it's up for debate, but depending
Yeah.
on the person's feelings.
Yeah, so biosphere is life. Anything. It can be plants, it can be animals, it's microorganisms, anything. It's biosphere. Includes all forms of life, from small to massive, concentrated near the surface in a zone that extends from the ocean floor upwards several kilometers into the atmosphere. There are certain organisms live in atmosphere. There are certain organisms lives deepest part of the ocean. So everything comes under biosphere. Okay? So this is the third part. The last one is called geosphere. Geo means earth or crust, earth's material. So geosphere based on, it is the study of the earth's crust, comprises rocks, minerals, mountains, everything comes under geosphere. So what are the four spheres earth is where consists of? Earth consists of, first one is hydrosphere, atmosphere, biosphere and geosphere. It doesn't have to be in order, but make sure that you know the four spheres. And I will, in the quiz, I'm going to ask like this. I'm just give you just an example of a quiz. Which one is not a part of the Earth's spheres? And I'll put as exosphere. And you can, so if you know that is not, then you just tick it and you get the points. Okay, now let's see. Based on the composition, the makeup of the Earth, Earth is divided into three different layers. Like you have a three-tiered cake. The center portion has one type of ice cake, strawberry cake. then chocolate, then top is different, icing, all if you take a transsectional, if you cut it sideways, you three-tiered wedding cakes. Those are likewise if you see a earth also if you cut it in half, like a half, you three layers. The outermost layer is called as crust. It's a very thin rocky layer. Then you have outer crust and inner crusts. So then mantle. The mantle is the second center portion of the earth, which has it's called mantle, which is about 2,890 kilometers thick layer of the earth. And most of the 82% of the earth's volume is in the mantle. So mantle is a big chunk of the earth. Then mantle is divided into two parts. So if you see the on page Earth Science System mantle. Mantle is divided into two parts, upper mantle and lower mantle. And upper mantle is again divided into two parts. What is the upper part, which is a rigid layer? It is called as rigid layer along with the upper crust. It is called as lithosphere. All these are quiz questions. The second one, the inner layer, which is a softer layer, that is called as asthenosphere. The words, if you are taking the quiz in the class, the wording is, spelling is very important. Asthenosphere.
So in a book?
It's in your book on page, say 18.
Page 18, okay.
Yeah.
I got the book pulled up.
Yeah. So the mantle, upper mantle, lower mantle. Upper mantle is divided into again two parts, which is the outer rigid layer is called as lithosphere. The inner softer layer is called as asthenosphere.
Oh, okay.
Then the innermost part of the earth is called as core. Core is again divided into two parts, outer core and inner core. Outer core is liquid iron and is made up of liquid iron and other metals and nickel. But inner core is a solid alloy. This is very important. The inner core is a solid ball or alloy of iron and nickel. This is very important. Inner core is a solid ball of iron and nickel. And now somebody might ask me, why inner core is solid? Because inner core is solid because of the extreme pressure coming from all sides of the earth. That's why. If I ask you a question, what is the reason the inner core is solid? Because of extreme pressure. That's the answer. So Earth's internal layer, if you see that is the mantle. Okay, wait on that. Earth's internal layer is, by sorting of the material composition, differences result in the formation of three layers because of the compositional makeup, gradient of the makeup. That is divided into three layers. These are the crust, mantle, core. Out of these three, which is the biggest part, chunk of the volume? Which is the biggest part? It's mantle. It's 82%. Now, go ahead.
The mantle is made up of two parts, the upper and lower.
Mantle and lower mantle.
And then the
upper is divided into lithosphere and asthenosphere.
Okay, okay, I got that.
The inner mantle is not divided, it's just one.
Okay.
Then the third, the earth is also divided into layers based on the physical properties, such as solid, liquid. Outer core, the crust is all solid, but as you go deeper inside, it becomes liquid. But it comes to the core, it becomes solid because of the extreme pressure. So, okay, what is the next slide? Okay, now let's see. The next slide is, okay, crust. Let's say these are, you don't have to know exact values, but just remember which one is thinner, which one is the major chunk, like that. Crust extends only 7 to 70 kilometers. The depth of the crust is only 7 to 70 kilometers, which is 5 to 40 miles. 5 miles to 40 miles, go deeper in the earth, it is crust. Now comes, so all the buildings you see, everything, skyscrapers, and we are walking, we are sitting in this classroom, we are sitting on the crust. It's like a bread has a crust, thin layer. The crust is of two types, this is important. Highlight, this is a quiz question. Continental crust and oceanic crust. Continental crust is a less low density. Oceanic crust is heavy and high density because it has to bear the pressure of the water. That's why it will be more thicker. They both are made up of different type of rocks. Continental crust is mostly made up of what do you call this? What's that?
Silica?
Yes, mostly silica type of rocks. It's called a granitic rocks, light colored rocks. But as you go to the oceanic crust, it is made up of darker colored rocks. So it's called mafic rocks. It's a darker color. It has more iron content in it. So oceanic crust, because of the higher iron content, the oceanic crust rocks are more denser, and that's why, and it can sustain the pressures of the waters. Can anybody go into the deepest part of the oceans? No. Humans cannot go because humans cannot take that pressure. Only remote operated vehicles can go, ROVs, which are called as ROVs, or remote controlled vehicles. They only can go inside the deepest part of the ocean. Why? Because the pressure of the water above is so high, human bodies cannot take up that. So that's important. So continental crust, which is made up of granitic rocks, you'll study the next chapter that said the oceanic rocks are made up of the darker color mafic rocks. Okay. Mantle extends to the depth of about 1800 miles. After 70 miles, you go deeper 1800 miles. That's the mantle. Then mantle is again divided into upper mantle, lower mantle, and upper mantle is divided into lithosphere and asthenosphere. Then comes core. Core is inside. After 1800 miles, deeper is the core, and that is inner core is a solid layer, outer core is liquid iron. And why it is since outer core is liquid iron, that's the reason we are still surviving today. Otherwise, because of the solar radiation, we would have already died. We would have wiped out. Because sun has a harmful solar radiations coming onto the earth's surface. But because of the outer core is liquid iron, our earth acts like a magnet. And since earth acts like a giant magnet, our earth has something called as magnetosphere, which is a protecting layer above the earth atmosphere. And this protecting layer protects us from the harmful solar radiation coming. And since it's a magnet, magnets have strong strengths along the poles, North Pole and South Pole. So sometimes when you see the solar radiation falling on the earth, and what happens is they get entangled. This magnetosphere protects us from the harmful solar radiation. It deflects them back. Sometimes what happens, it gets tangled in that magnetosphere and it flares up. That's why you probably heard about northern lights and southern lights that happens at the poles. That's because of this, which is called as auroras, right? Northern auroras. So that happens only at the poles because of the same reason. And we are alive today, and I am teaching earth science class because of the presence of outer core being liquid, and it has a magnetic sphere. Earth acts like a giant magnet. And that is another reason different countries were discovered. When they were Vikings, when they were seafaring, they didn't have magnetic needles at that time. They didn't have those fancy electronic iPhone watches. to have those needles on those watches, right? Or your cell phones. How people used to fare seas, oceans. They in the earliest time, during Greek times, there was celestial bodies, based on celestial bodies. But on a cloudy day, you cannot see the planets, right? So that time they wanted to discover something where they can fare seas easily without getting hindered by these clouds and climate, different cloud patterns. So what happens at that time, a different part of the world, in China, people used to travel using something called, it's a mineral. It comes from the earth's crust. It's a rock which is called as magnetite, and it's called a lodestone, and it's made of, see, it contains iron in it, and since it contains iron in it, it acts like a magnet. So since it has a magnetic property, it acts always a magnet has two poles, a north pole and a south pole. And remember, opposite poles attract, like poles repel. So what happens, since Earth also acts like a magnet, Earth has a magnetic north pole and Earth has a magnetic south pole. So what happens is, this lodestone's north pole attracts to the Earth's magnetic south, and the lodestone's north pole attracts to the Earth's magnetic south. Opposite poles attract, and based on that, they used to tie like this. They used to tie the rock with a string, and they used to suspend, and wherever it moves, the north, and that's how the suspend if you see the magnetic needles, so they suspend, right? It's a small metal suspended, right? And it gets deflected, and that is exactly the same principle, the rock. So somebody came up with how about if I take a small needle and put it on a small pointed pivot, will it rotate? Yes, because it acts like a magnet, and that's how magnetic compass got invented. So all these are interlinked. Let's see, what are plate tectonics? Now comes plate tectonics. This is another theory. This is very important. Plate tectonics is a theory that proposes that the entire Earth has outer shells consist of individual plates. You remember the Earth's crust and the upper mantle together called as lithosphere, right? I just explained. The Earth's crust and upper part of the upper mantle is called as a rigid layer. It is called lithosphere. And this rigid lithosphere is floating on a liquid or semi-solid softer layer below, which is called asthenosphere. It's almost like sliding past, and that's why these plates are rigid layer, and that's why these plates are moving. That's why when the plates move, earthquakes comes. So plate tectonic is the theory that proposes that the Earth's outer layer or outer shell consists of individual plates that interact in different ways, and thereby producing earthquakes, volcanoes, mountain buildings, and Earth's crust itself. So I'll explain how. So if the plates are, if you have two plates, I'm going to show you like this. I'm going to show the example here in the class, then I'm going to show you on a whiteboard for online students. So if you see if these are two plates, if plates are moving up to facing towards each other, this is called as convergent plates. If they are moving apart from each other, these are called divergent plates. When they neither moved towards each other nor passed away from each other, but they passed slide with each other, that is called as, that is the third one, that is transform fault boundaries. And now every action has a reaction. If they come together facing each other, it causes mountain buildings. If they're facing up, if they're drifting apart from each other, it causes a new seafloor spreading. But and volcanic eruptions also comes out. And if they passed one another, it leads to earthquakes. So I'm going to show you what I explained. I'm going to show you to the participants on here on a whiteboard. So let me erase all this. Hang on, how to remove. Hang on, I'm trying to erase everything. Okay.
What's the third one called?
Transform fault. Transform fault.
Transform fault.
Yeah. So I'm trying to erase this, clear all my drawings. Good. Okay. So let's see. I'm going to say, consider this is one plate. Consider this as one plate. This is another plate. If this is plate A and plate B, if these plates come together facing each other, this is called as convergent boundary, and this leads to mountain buildings. Mountains are built, they push together each other facing. If the plates are drifting apart, if this plate goes this way, this plate goes this way, that is called as divergent. When that happens, it leads to volcanic eruptions and new seafloor spreading takes place. When these plates move apart, the liquid rock or magma, you will learn that later, it fills in that gap and it gets solidified and it forms a new ocean crust, and that is called seafloor spreading. The third type, they neither come together nor drift apart, but they slide one another. This goes this way and this is coming this way. They slide one another, and that is called as transform fault boundaries. And when that happens, that's where it causes earthquakes. Is everybody with me? Whoever is online? Yeah? Okay, good. Yeah, if I hear one yes, that's enough. So one is when they come together, it is convergent boundaries. When they move apart, it is called divergent boundaries. When they slide one another, it is called transform fault. Everything there are different phenomenon happens at different times. I'm going back to the slides. Can you see my slide back?
Yep.
Okay, good. Okay, that's what is this, you see. Convergent boundaries when plates move together, divergent when pulls apart, transform fault boundaries when plates do not push together or pull apart, instead they slide one another. So there. Okay, now let's see the Earth surface. Is Earth flat, or do you see Earth has also different, the Earth has continents and oceans, right? Is Earth only dry land, or does it also has a wet wall? It's covered by water. It's covered by water, 71%, right? So the dry land is called as continents. The flat features that have appearance of plateaus which are protruding from the Earth, those are called as continents. And the continents contains, which are called as a high-rise, prominent topographic features of the continents, which are above the sea level. Those are called as mountain belts. You have different types of mountain belts. Then what are shields? This is another important. The shields are nothing but these are expansive flat regions composed of only deformed crystalline rocks. Those are called as shields. Okay, the mountain belts and shields, these are different. These are surface of the earth. Now what is about ocean basins? See, as I told you, surface of the earth is divided into continents and ocean basins. Then continents are divided into, these are the mountain belts and shields. Mountain belts are protruding, the prominent topographic feature. What are the flat regions are called as shields. Likewise, ocean basins are, these are mountain belts, these are shields. These are ocean basins. Ocean basins contains continental margins. So these are, the ocean basins are of three types, depending upon the inner depth as you go inside the middle part of the oceans. So I'm going to draw here. Can you all see when I'm drawing here?
Yes.
Okay, so this consider this is the shoreline. This is the shore. This is the inside is the ocean spot. So the first one is continental margin. This continental margin is from the shoreline to a certain inside, certain distance. This distance is called as continental margin. And after the continental margin, it gives rise to deep ocean basins. This is the deep ocean basins. And then after the deep ocean basins, which are innermost part, is called as mid-oceanic ridges. This is mid-oceanic ridges. Here is deep ocean basins, but here it is continental margins. So remember, these are again quiz questions. Ocean basins are divided into continental margin, deep ocean basins, and mid-oceanic ridges. Continental margin is again divided into three parts. First one is continental shelf, continental slope, continental rise. Continental margin is divided into three types: continental shelf, continental slope, continental rise. You will study more about this in detail in oceans in chapter 14 and chapter 13. Right now you just remember these ones. Ocean basins are divided into continental margin, deep ocean, mid-ocean, deep ocean basins, and mid-oceanic ridges. And deep ocean basins, what are the features which are present in continental margins? Continental shelf, continental slope, continental rise. Likewise, deep ocean basins also has different features. What are those deep ocean basins? Have abyssal plains, and they have deep ocean trenches. They have sea mounts. What is a sea mount? It's nothing but it's a volcanic mountains inside the earth are called as submerged mountains. See, people might think the ocean is all flat. No, ocean is more diverse than what you see on the surface of the earth. You see mountains, valleys, then plateaus, and so much stuff. It's not even, and that's why studying the ocean floors is called as bathymetry. Bathymetry is the study you will study in the later part of the chapter 14 and 13, called bathymetry. It's charting the ocean floors is called as bathymetry. Now, what is there in the mid-oceanic ridges? It's just a prominent ridges. It's like if you see a football or soccer ball, you see the seams, right? Seams around those patches. Those seams are nothing but these are mid-oceanic ridges. Those are like they connect all. You see a lot of volcanic eruptions happening along these mid-oceanic ridges. So these are the. Okay, next one. Okay. Okay, next one, next slide. Okay, so these are just the different layers. This is a picture in your textbook. You have in textbook also.